Different metallurgical operations are concentration of the ore, conversion of the concentrated ore into its oxide, reduction of the ore, and finally refining. Today's discussion is about metallurgy of zinc. The ore of zinc is zinc blend with the formula ZnS. First, we have to do what is concentration. So, concentration should be done with froth flotation process. Why did we choose froth flotation? Because zinc blend is a sulfide ore. Sulfide ores are generally concentrated by froth flotation. After getting the concentrated ore, we do the next process that is known as roasting, wherein the concentrated ore is heated in the presence of oxygen. Then it is converted to zinc oxide with the formula ZnO. Next step involved is the removal of the oxygen to get the metal, and this is done by what is called reduction. So reduction is effected by heating it with a common reducing agent, that is coke. So on heating it with coke, zinc oxide get reduced to zinc and we get the impure zinc. What is special about zinc? We know that zinc is a d block element and so it is having a completed d orbital. Its atomic number is 30 and so it is having completed D10 configuration. With the result, you find that the number of unpaired electrons present in zinc is very less, due to which it is a volatile metal. As a result, we use the method called distillation to do the purification of zinc, where zinc with the low melting point is heated in a round bottom flask and the vapors are collected to get pure zinc. We shall just write down the equations involved in roasting and reduction. Here, the oxide taken is the ore taken is zinc sulfide. When it undergoes roasting in the presence of oxygen, it will be converted to zinc oxide plus sulfur dioxide. Sulfur dioxide rises up. So here, if we add 2 in front, you have 2 ZnO. Sulfur becomes 2, so this side it becomes 2. Total of 6 oxygens are there, due to which we have to balance it like 3O2. Now coming to the reduction step. Now zinc oxide that we have is treated with coke in the presence of heat, when it gets converted to zinc and carbon monoxide. So these are the relevant equations in metallurgy of zinc. Next, you will be learning about extraction of copper from low-grade ores. Process of electrometallurgy or hydrometallurgy is used for isolation of copper from low-grade ores. First, the ore is leached by a suitable acid so that the solution containing copper will react with either iron or hydrogen to form the metal copper plus Fe2 plus. Whereas in the case of reaction with CO2 plus and hydrogen, the product form will be copper plus hydrogen ions. We'll now split both these reactions into oxidation part and reduction part. First equation becomes Cu2 plus 2 electrons becoming Cu value of reduction is 0.34 volt, whereas iron changes to Fe2 plus 2 electrons. The E0 value will be 0.44 volt, that is E0 oxidation. So the total reaction will be Cu2 plus Fe giving Cu plus Fe2 plus. With the result, the E reaction will be 0.78 volt. We know that delta G0 is equal to minus NFE 0. E0 value is taken as 0.78 volt. With the result, delta G value is negative. So, the reaction becomes spontaneous. We shall now split the above reaction into oxidation part and reduction part. We have the reduction part as Cu2 plus 2 electrons becoming Cu. So the E0 reduction value will be equal to positive 0.34 volt. Coming to the next part, H2 changes to 2H plus 2 electrons. Here, E0 of oxidation will be 0. So, with the result, the overall reaction becomes Cu2 plus hydrogen becoming Cu plus 2H plus. The E reduction value or the E of the reaction will be equal to plus 0.34 volt. As told earlier, delta G0 value is equal to negative NFE. E0 value we have got it as positive 0.34 volt, and so delta G value will be negative. With the result, we find that the values or the reaction becomes spontaneous in this case too. So, we are able to isolate copper from low grade ores using hydrometallurgy.